Hello guys, hello everyone and welcome to the class. Now today in this video I'm going to solve questions from your previous year of IIT-JAM, that is IIT-JAM 2019 exam. And I'm going to take questions from molecular spectroscopy in this video, right? So this is one of the very important topic from your physical chemistry portion, and it carries around like a good weightage of marks from the physical chemistry, from the exam point of view, right? So let's talk about it now. Going into the before going into the topic, let me just tell you about the total number of questions which are generally asked. So you will get around like 2 to 3 questions from this particular topic. Okay, generally 2 to 3. Sometimes you can also get 4 questions. It totally depends. But yeah, the usual trend is 2 to 3 questions. Marks weightage is around like you will get 6 to 8 marks from this topic. Sometimes even 10 marks also you can get. So it's a good weightage topic from the exam point of view. Difficulty level, I would say that generally it varies from moderate to difficult. Okay, so it varies from moderate to difficult. But yeah, I would rather say the questions are quite difficult because they are tricky questions which are asked from this topic. So we'll take some of the questions in this video and let's try to analyze them, right? Okay, so going further, I would say like I would take the first question over here, which was asked for 1 marks. The question is pretty simple. Okay, it says that the number of vibrational modes or carbon dioxide molecule that can be detected using IR spectroscopy. Now you know IR spectroscopy determines about the vibration, about the frequencies, right? The vibrational frequencies. So it basically depends upon them, and it depends upon how many vibrational degrees of freedom you have. So the number of vibrational modes will be the number of vibrational degrees of freedom. That's how we do basically all the questions. So but here this is quite tricky. Okay, that's what I'm going to tell you. See, the vibrational number of vibrational modes, like vibrational degrees of freedom or number of vibrational mode for linear molecule. Okay, that is given by this formula, that is 3n minus 5, right? So that is the formula to calculate number of vibrational modes for a linear molecule, 3n minus 5. So let's use that. N is the number of molecule in that. Now you have carbon dioxide, you have 3 atoms over here, so n value will be 3 over here. So that means 3 into 3 and minus 5, that is going to give you 4. So there should be 4 vibrational modes in the given molecule. So let's try to draw them and see that how they will look actually. So one will be like carbon dioxide, one will be your symmetric stretching, that is going like this. So this is what, this is symmetric stretching. Okay, symmetric stretching. The second one can be like asymmetric stretching, in which it would go in this direction, this would go in this direction, and this in this direction. So this is what, this is asymmetric stretching. Okay, I'm not going into the IR activity of that, but yeah, that also you can assign. Symmetric stretching will be IR inactive, this will be IR active. Okay, next is your bending. Okay, so you will be having a bending like this, where this and this oxygen will go in the upward direction, carbon will go in the downward direction. Now this will be called as delta XZ, because for the general sign convention we take Z axis horizontally upside, X axis like this, and your Y axis like this. Okay, going inside the screen like that. Okay, so this is, everything is happening in the XZ plane, so that's why we call it delta XZ. You can have one more kind of bending. That's what the 4 actually tells you, that particular bending, in that particular case you would have these 2 oxygen going in this direction and this in this direction. So this will be your delta XY. Okay, that's what you can see. So delta XY, because this is happening in the XY plane. Now when you look upon the molecular orbitals of these, so your XZ and YZ, these 2 planes are actually degenerate. Okay, the energy level of these 2 are degenerate. So what does this degenerate means? It means that they have similar energy. Remember, XZ and YZ, they are always degenerate. So whatever is happening in the XZ, if the same kind of thing or the same kind of vibration is happening in the XY plane, in that particular case, they will just give you a single peak. So what is the total number of peaks then? So one peak because of symmetric stretching, the other one because of asymmetric stretching, and one singular peak because of both of them. Both will be degenerate. So that's why, although the formula answer is coming 4, but the correct answer should be option number 3, that is like 3 peaks in this particular case. Okay, so that's what the trick is, and that's why it becomes a little tricky to solve questions from this topic. I hope you guys understood it, right? So let's move on to the next question. Okay, so here it says this was asked for 2 marks over here now. It says correct option for the number of bending modes of vibration in each, like you have H2O, you have CS2, you have SO2 molecule respectively. So you have to tell the number of bending modes in them. So to answer this particular question, first of all, you need to know a very basic formula. Okay, that's what I'm going to tell. The same we have used in the previous question, but yet I'll just take that. Okay, so vibrational mode. Okay, I'm just writing vibrational modes, and that is given by, for linear molecule, the formula is 3n minus 5. Okay, that's the formula for your linear molecule. Now see, these vibrational modes can be of 2 types. They can be either they can be stretching mode, okay, stretching mode, and the other one can be your bending mode. So you should know how many stretching and how many bending modes you will have. So the stretching mode is n minus 1 and the bending mode is 2n minus 4. Now let's say the molecule is non-linear. In that particular case, if the molecule is non-linear, then the total number of vibrational modes is 3n minus 6, right? That is the formula for non-linear molecule. Among them also you will have stretching mode, okay, stretching mode, that will be given by n minus 1, and you will be having bending mode. Okay, bending mode will be given by 2n minus 5. Okay, so this formula you should know in order to calculate the number of bending modes. Now over here in the molecule you can see that CS2 is a linear molecule, whereas H2O or your SO2, both of them are non-linear molecules, right? So for both of them this formula will be followed, and for CS2 you will follow this formula. So for CS2 how much you will get? Now you have over here 3 atoms, right? So 2 into 3 and minus 4. So 2 into 3 will be 6 and minus 4 will be 2. So this, whatever you calculated, this you calculated actually for CS2. Okay, for CS2 molecule. So fine. For CS2 we got 2. Now talking about this particular over here, for H2O or for SO2, both of them also have 3 atoms. So the n value will be 3. So 2 into 3 and minus 5. So 2 into 3 is 6, minus 5 is 1. So basically whatever you calculated, this you calculated for what? You calculated for H2O and for SO2 both. So for both of them, you will have 1 bending mode. So the answer will be like for this one, for this 2, and for this one. So 1 to 1. That means option number 4 is going to be the correct option. Now this is very important formula. Okay, just remember it and just write it down somewhere. It's very, very important. Alright, so having said that, let's go to the next question then. Alright, so now this last question for this video is from your NMR part, and this particular question is a numerical answer type question, right? The question says that the magnetic field strength required to excite an isolated proton to its higher spin state with the electromagnetic radiation of 300 megahertz is how many Tesla? Now they have said that round off to up to 2 decimal place, and the gyromagnetic or magnetogyric ratio of proton is given to us in the form of in the units of radian per Tesla per second. So let's try to solve it, that how we are going to do. So basically your Larmor frequency, okay, Larmor precision or Larmor frequency is given by this particular formula, that is nu is equals to gamma b naught or beta or b naught, okay, divided by your 2 pi, okay, where gamma is your gyromagnetic ratio, d naught is your magnetic field which you are providing, nu is the frequency. Now it's given, right? Frequency is given to us. Let me just write down the value. So frequency is given to us as 300 megahertz, okay, or you can write down that 300 into 10 to the power 6 hertz, okay, that is the value of, this is hertz, okay, so that is the value of your frequency given. And also you are given with, yeah, so you have to just calculate it b naught, okay, so your b naught will be equal to frequency, or you can write down like this, 2 pi nu divided by gamma, okay, so just put all the values over here. So it will be like that only. Pi is 3.14, nu is 300 into 10 to the power 6 divided by gyromagnetic ratio, that is 26.75 into 10 to the power 7, okay. Just solve this question, just solve this equation. Use the calculator provided in the exam, just you make the best use of that and solve this, and after solving you will get 7.04 Tesla, okay. So that is going to be the correct answer for this. So 7.04 0.04 Tesla is going to be the correct answer for this particular question. So that's how you can solve this particular question. It was very simple, just based upon a formula. But yeah, if you know the formula, then only you'll be able to do, right? So Larmor frequency or Larmor precision frequency is an important formula from this topic. All right, so let me just summarize everything. Level of questions, I would say that they were difficult. Okay, all of them were quite difficult. I would not say they were easy, right? I will be very honest over here. Yeah, so all the questions were difficult over here. Concepts which were used in the first question, there was like number of vibrational degrees of freedom, okay, or vibrational modes. Vibrational modes, that's what the first question was about. The second was about number of bending modes, okay, number of bending modes. And the third question was from your NMR spectroscopy. NMR spectroscopy, basically from the physical portion of that, or basically from the Larmor frequency. So these were the three important concepts which are used in this. Useful tip, I would say that write all the formula, okay, like learn or summarize or whatever you can do. Just learn or just like remember all the formula, okay, all important formula, okay, and solve previous year's question. That is very, very important. And also refer some good books, okay, refer standard books for this. All right, so that's all for this video. I would just sum up everything, and I hope whatever I have taught in this video, whatever questions I have taken, they were quite useful to you. You guys understood them well. So thank you so much for watching. That's all from my side for this video. I'll come back with a new video with some more questions over there, right? So thank you so much for watching, guys, and have a great day. Bye-bye.